So for our next presentation, it's Practicality Beats Purity, the Zen of Python's Escape Hatch by Christopher Neugebauer. Christopher is an Australian developer, speaker, and serial community conference organizer who presently lives in the United States. He recently served as the director and vice chair of the Python Software Foundation, and when all this is not currently preventing it, he is a co-organizer of the acclaimed North Bay Python Conference, a boutique one-track conference run in a live music venue in Petaluma, California. By day, Christopher is an engineer at Toolchain, working on the open source Pans build system, helping make Python's testing, correctness, and style tools accessible and fast for developers, no matter how big their code base is. Let's give a large, warm round of applause for Christopher.
Hello, everyone. Great to see all of you here. Just need to get some water off my screen, which I just spilled. So, over the last few years, I've been giving talks at Python conferences about what makes good Python code. And I often do this by talking about how Python approaches ideas from other programming languages. Today, I'm here to talk to you about the Zen of Python. Now, since time immemorial, we have been using the Zen of Python to help us figure out how to write good Python code. And there are many people here who I think enjoy getting into arguments on the internet. And when we get into those arguments on the internet, we often use the Zen of Python as fuel for those arguments. So I think it is a great time for us to be talking about the Zen of Python and its limitations, and to talk about whether the Zen of Python does what we think it does. Now, I've been a huge fan of the Zen of Python for many, many years. This was reinforced for me at a talk at PyCon Australia back in 2011, when Richard Jones gave a fantastic deep dive talk, which was simply titled The Zen of Python. And his talk showed how the Zen of Python was used within the Python codebase itself and the standard library of Python. Now, sadly, that talk wasn't recorded. You can't go back and watch it. But for me, it really shaped how I think about writing Python code, because I saw how to put the Zen of Python into practice. And it taught me ways to recognize whether some code was good Python or whether that code was bad Python. But I gave a talk a few years ago, and in that talk, I looked to the Zen of Python to answer a question in that talk. And for the first time, I was left bereft. I had found a design problem in some Python code that I had written, and the Zen of Python could not save me. And that is what I have come here to talk to you about. Tim Peters' 20 Python Theses. And no, that spelling up there is exactly how he introduced it on a mailing list. Now, those 20 theses, of which only 19 of them have been written down, have since become known as the Zen of Python, or PEP20, or that thing that appears in your terminal when you type import this. And here are those 20 theses, of which only 19 have been written down. Now, immediately, in that very mailing list thread where Tim introduced it, people thought it was fantastic and it described everything that they thought that Python was about. It was concise, it was opinionated, and explained in very, very clear terms how Python wasn't Perl. And in the late 1990s, that was very, very important. Now, in the years following, people started to identify languages with what I'm going to call a prescriptive design philosophy. A good example of such a language is Java, which was intended to be familiar to C developers, just like C++ was, but without all of those ways that C++ would let you shoot yourself in the foot. Now, looking at the Zen of Python, which came around that time, especially those first few lines of it, it also made people think that Python had a prescriptive design philosophy. This was in contrast to, say, Perl. Now, for the longest time, I've referred to the Zen of Python. I've referred to it when introducing speakers at conferences. I've used it to answer questions that are raised in my own talks. I've used it to solve design problems in my own code. I've definitely thought that the Zen of Python was evidence that Python has a prescriptive design philosophy. But it isn't that. Today, I want to show you why the Zen of Python is not prescriptive and why it is a terrible way to settle arguments about the right way to do things in Python. So today, we are going to look at two design decisions that were made after the Zen of Python was written that appear to have ignored the Zen of Python. Today we're going to look at some code that the Zen of Python must think is reasonable, but clearly isn't. And we're going to look at whether the Zen of Python ruins our understanding of why Python is the way that it is. So with that, I mentioned earlier that I got confused by the Zen of Python in a talk. And the Python feature that confused me in that talk was the decorator. So decorators exist because sometimes in Python you need to modify the behavior of a function or a callable. People have been modifying the behavior of functions since well before decorators existed. Now, one popular way to do this was with a thing called the decorate pattern. The decorate pattern looked like this. You will define a function like that, and then you'll pass that function into another function, assigning it back to the original name. Now, this is fine for short bits of code that fit on a single screen, but things can really start to fall apart quite quickly. If you need to decorate the same function twice, things started to get a bit repetitive. You have to decorate your function from the inside out, so the last decorator that is applied is actually the outermost behavior at call time, which doesn't make a whole lot of intuitive sense, and also suffers from a poor concept grouping. The decorator can really substantially change the behavior of a function, but here it appears at the end of that function body. And if your function is really, really long, that might not even appear on the same window. And this can make for really unreadable code. And as we know from the Zen of Python, readability counts. So the PEP that introduced decorating syntax gave us syntax for the decorate pattern. And now we have decorators. We know that def means we're defining a function. So if we see a decorator, we intuitively understand that that function is going to have some modified behavior. And in this case, just by reading it, we know that this function is synchronized and that it's a class method. Now this won't be surprising if you've seen me talk about decorators before, but this understanding of a decorator isn't exactly true. Because putting a decorator before a function definition doesn't actually change the behavior of a function. It actually changes the definition of a function in its entirety. And to demonstrate that, I'm going to show you what I mean here. Say you define a function called squares, which is a thing that multiplies a number by itself. Now you can call that function and you get a value out of it and everything is absolutely great. Now here is a decorator function. It's called apply. When you decorate a function with it, you provide a thing called transform, which is a lambda that accepts a function as a parameter. When you decorate a function with this apply decorator, it will call that transform function with the function that you're decorating as its parameter, and instead of returning a callable, it will return whatever that transform function returned. And so if we take our squares function and decorate it with apply, and we can pass in map as our transform function, after we define our function, squares is no longer a callable, it's a list, even though we've used the def keyword to say this is a function, because that's what our transformer returns. So we created a function using def to be called once at definition time, and then we discarded it because that's what our decorator does. We define ourselves a callable, but we end up with a variable containing a list. You know, the fact that the thing that we define is no longer necessarily callable, it's not obvious from the decoration syntax. But it's there pretty plainly in the old decorate syntax. There is nothing that says that this thing with an equals sign after it has to return a function. And that brings us to the Zen of Python, which says that explicit is better than implicit. And in Python, def name means that name is a callable pretty explicitly. It's a contract with you as a developer, and decorators let you break that contract quite easily. So could they have done better? Well, what if we made it so that things that decorators put in their place had to be callable? That would solve exactly the problem I've just described. But things like descriptors, properties, which is something that I think is very Pythonic, are also implemented using decorators. Once you decorate a method with property, you don't call the method you defined using the call syntax, the parentheses. You call it by accessing or assigning to an attribute and an object. So the method you define gets called completely as a side effect of some completely different operation. And you have to know that this property thing does some weird behavior modification. So we see here that decorators turn function definition into implicit behavior that depends entirely upon what a decorator does. So if we follow the Zen of Python, which says that explicit is better than implicit, well then decorators must not be Pythonic. So now we're going to skip ahead 13 years of Python evolution into 2015, which was a very interesting time in the core Python development world. Because Python in the intervening years had got popular, and people who had never been involved in language design before decided to start contributing to design discussions amongst core developers on mailing lists. And these people who dropped into Python dev came from a generation of Python developers who had learned to solve design problems using the Zen of Python. And they knew that simple is better than complex. And there is no better demonstration of Python's simplicity than looking at the first program you write in Java. You need to know an awful lot about how to program to write hello world in Java. You need to know about types. You need to know about what classes are. You need to know method declarations, and Python's version is just so much simpler. But this simplicity is limited. Python requires you to test behavior with unexpected types. Automatically translating code was difficult, which I think really shot us in the foot when we were trying to translate between Python 2 and Python 3. And tools like IDEs were far less reliable as a result. And as the Zen of Python says, explicit is better than implicit. So the solution was to use a thing that had already existed in Python for a few versions to let you provide argument and return hints. And so now you can specify a function's contract with its callers, and these can be automatically tested by a type checker. But in doing so, things became less simple. Providing type hints is an extra piece of complexity that just wasn't there previously. And as you add type hints, your code could get crowded or verbose or other things that remind people of Java. But on the other hand, type hinting resolves ambiguity that was previously difficult to resolve. So basically, type hinting, it laid bare a contradiction. You had to choose between simplicity or explicitness. You have to choose between ambiguity or ugliness. You have to choose where to accept your complexity. This is an argument that the Zen of Python just can't resolve. And so we see two cases where the Zen of Python just does not help matters at all. And if you think the Zen of Python is there to tell you exactly what Pythonic choices are, well, then you are probably asking yourself a question right now. So the answer to that one also comes from reading the Zen of Python. We saw that decorators are a feature that significantly improve the readability of Python code. But in doing so, they take away a feature of Python with quite explicit behavior and they turn it into something implicit. And we saw that adding type hints takes the simple structure and understanding of Python code and makes it more complex. And we saw that not including type hints means that expected behavior of functions becomes implicit. These are two cases where the Zen of Python does not guide you towards a good solution. And as Tim Peters said when introducing it, if the answer to any Python design issue is not obvious after reading the Zen of Python, you should give up. So if you take the Zen of Python at face value, you have to say that it has absolutely failed to guide Python in the right direction. But I hear you say these are special cases, they do important things. Well, the Zen of Python also says something about that. It says that special cases aren't special enough to break the rules. But almost as an afterthought, it also says that practicality beats purity. What does it mean for practicality to beat purity? Well, it means that not everything fits into those catchy little boxes that the Zen of Python has created for you. It means that sometimes you need to make choices. By the Zen of Python, allowing implicit behavior means that decorators aren't Pythonic, but decorators encoded an existing use case. In the before times, when you wanted to decorate a function, you would need to sacrifice readability for functionality. You don't need to do that anymore. And as they were eventually implemented, decorators let you do everything that people were doing with the decorate pattern beforehand. It meant that every use case where people were decorating functions ended up being covered. And it allowed for innovations like property descriptors. Type hints solved a real use case that real Python developers could not solve with Python. Inferring the types that a function would accept or return was difficult. It limited the tools that you could use with older Python code. And if you believe that explicit is better than implicit, then Python's original approach to typing was not Pythonic at all. But it did make a practical choice for writing programs quickly. The solution isn't simple. Good type systems are inherently complex. Bad type systems make it complex to write code. But they enable simplicity in tests, in tooling, and in automatic translation. So Python chose a system where you could choose to opt out of static typing completely. So there's a rich and useful typing system for people who need it, and if you don't, you can opt out or you can choose something in between. And that's the very definition of a practical choice. If you prefer static typing, you prefer dynamic typing, you prefer a mix of both, you end up getting the programming language that you want. So Python design decisions value simplicity, explicitness, and a whole bunch of other things, but it also values practicality. This is a real factor in design decisions, but it acknowledges that not every design problem fits into rules. Or put another way, Python doesn't tell you how to do things. But the Zen of Python also talks about being able to do things. Indeed, it says that there should be one, and preferably only one, obvious way to do things. And this is an approach that has served the language pretty well over the years. Basically, it says that you should find some way to do something, and then keep iterating until it is obvious that that's the way to do something. But that means in order for there to be one obvious way, you need to try out a bunch of different other ways first. And quite often, one of the ways we choose on that path might seem like the one obvious way. I've given talks in the past where I would enthusiastically talk about multiprocessing or requests, because those were the one obvious way at the time. But they replaced threading and URL open. But today I wouldn't tell you to use any of those. I'd tell you to use async IO and AIO HTTP. These things became the one obvious way because someone decided the old way wasn't obvious enough. Finding the obvious way involves experimentation and a certain acceptance that there needs to be a way to do something. And generally speaking, Python is a language that gives you the tools that you need to bend things to your will. Things like Django's ORM are only possible because you can use Python to subvert normal behavior and replace it with something completely different. So I want to talk a bit about a feature that wasn't in Python for a very long time, but has now been there for a couple of years, which is the switch statement. And Python delayed so long having a switch statement that when it finally was ready to arrive in Python, it showed up in its more modern form of pattern matching. So say you have an API binding in some web service handling code that fetches an object like a user object. Now, pattern matching and static typing makes it a lot easier to process error cases exhaustively and handle them correctly, much better than exceptions do. So our binding will return a union, the success case or a failure case. And if you're going to use pattern matching to inline in your code, the code handler actually looks something like this. And this looks reasonably simple, but there's a lot of repetition. We're assigning to the same variable in lots of different scopes. And if behind the scenes, each block in the pattern matcher ends up returning a different type, you can really start to bump up against the limitations of the type checker. I ran this previous slide of code against MyPy, and it really doesn't like redefining the types of variables. So that's easy enough to fix. You can pre-declare the variable to have a common type, and everything works just fine. But at this point, we're referring to the same variable 4 times, and that's an easy thing to mess up. And this is a case where another language that I like, Kotlin, has got it right. In Kotlin, everything is an expression, and so you can use their switch statement equivalent, the when statement, which branches out and then stores the result of the branch that succeeds as the value of the overall statement. And I'd like to be able to do something like that in Python. So can we do that? Well, instead of having a completely inline matching block, we can put it inside an inner function, and that completely placates the type checker, and it saves us from having to make sure we get the variable name exactly right in both blocks. Like you get a return, which is, you'll get a syntax error if you type the wrong thing. But it's still not right. It suffers from poor concept grouping because we don't make it clear that this is like a one-off thing that we're not going to reuse. What we'd really like to do is define that pattern matching block and have it be saved to a variable, just like Kotlin, and we already have the tools to do this, as it turns out. So if we were to define a simplified version of apply, for which I showed you earlier in this talk, one that doesn't take a transforming function but calls the function body immediately, storing its result, I'm just going to call this as variable. You've probably got an idea of what it does now. So we can take our existing code with the inline function, and then we use that as variable decorator before the function definition. And this actually works. Response here is a response object in a variable, and it even passes type checking in MyPy. Now, of course, this isn't nearly as elegant as the purely syntactic implementation in Kotlin, and it's not great Python either. We're already like 3 levels of indentation deep here. It's 4 if it's inside another function, 5 if it's inside a method and a class body. So this is probably not the final obvious way to do something, but it solves a problem for me right now, and I can see situations where something like this could be an obvious way. And as the Zen of Python says, it says, now is better than never, which is to say that if you need something, maybe you should implement it with the tools that you already have. But it also provides a word of caution. It says that never is often better than right now. And so if we follow the Zen of Python's guidance, we find ourselves in a situation where the only way to do things involves doing things that aren't obvious. And so we probably shouldn't do that because that's bad Python as well. But what we've seen here is that Python grows because people try things out, decide that the best current approach doesn't work, and they improve upon it. So what is practicality here? It may mean that there just may never be a good way to do something, even if it seems obvious. And so I spent more than 10 years thinking about Python in a certain way, guided by the Zen of Python. And I found myself confused by the advice of rules that we use to write good Python code. And I've been thinking about this fundamental assumption about how Python wants us to do things, this prescriptive design philosophy that I thought that the Zen of Python gives us. Or, put another way, can we follow a set of rules, any set of rules, and always end up with good Python code? And over the course of today's talk, we've seen that even in these fundamental design cases that have resulted in syntax in the language, the Zen of Python, PEP 20, gives us contradictory advice that's impossible to follow. Accepting any one of these 20 theses as your favorite often means giving no weight at all to another of them. So it's not about whether following the rules will give us good Python code. It's about whether we can follow the rules at all. So PEP 20 doesn't help us be prescriptive. But there is a PEP that is all about being prescriptive, which is PEP 8. PEP 8 is a style guide. A style guide should tell you exactly what to do. It tells you what to do. It's the very definition of a prescriptive PEP. It should be exactly what we want here. But if you actually read PEP 8, as far as even the first heading, you are confronted with this. It says, a foolish consistency is the hobgoblin of little minds. So what does that mean? Well, it doesn't mean that it's bad to be consistent. In fact, it means quite the opposite. It means that you can be consistent, but you shouldn't be mindlessly consistent. It means that you need to think, and you need to consider whether it makes sense to be consistent. So the most prescriptive of all these PEPs says that you shouldn't be foolishly consistent. Python is not prescriptive, but it's easy to think that it is. It isn't. Python is opinionated. It is a language that has a strong opinion about how things should be done. And the Zen of Python is just a list of one man's opinions. Mind you, I think they're generally pretty good opinions for the most part, which you can use as guidelines to design better software. But they are just that, opinions. And opinions, no matter how much you agree with them, aren't actually rules. No matter how much your favorite part of the Zen of Python guides your development, it doesn't mean that it's the only factor. Remember that different people have different use cases, and Python grows as a language, as a community, because we support those use cases. Keeping a narrow view on the use cases that you value doesn't keep the language simple. It just keeps it simple for you. When problems come up that Python can't solve, you need to keep an open mind that people are actually having the problems that they say that they are, and that we can make Python simple for them too. That, I think, is a guiding principle of the language that we use. So while Python is an opinionated language with a strong design aesthetic, it's that way because the people who've designed Python made choices about how to improve the language. So if you want to write good Python code, sometimes that means valuing some design opinions more than others. Sometimes both opinions you must choose between are in the Zen of Python. So how do you choose? Value practicality over purity. Thank you. I will have notes to this talk, including implementations of everything I've shared, up on my website at chrisjrn.com. You can toot at me on the Mastodons, and thanks to everyone here at PyCascades for making this year's event happen. Thank you all.